We will code AI from scratch that generates images. We will catch up to XAI, OpenAI, Anthropic as open source, but first we need to start simple. So first we will generate these images of these digits. Let's understand how this works. So I have this code and it's actually training. Here you can see it's training. It's just gonna take 1 minute for this to finish training. So right now I'm showing these generated images in console. They look cool, but let me show it in real image. The training script is very short, just 159 lines of code to train this model. Here, this is example, so we train just like less than 1 minute. So this is number 1, number 2, number 3, they ain't looking so much like these numbers. Number 7, okay. What if we increase the training time? And I'm using single GPU 4090 on Novita AI. This is the cheapest on the market that I know of, 18 cents per hour if you choose spot billing, URL below. So I just told AI Claude to make it train 10x longer, and this vibe coding is so easy, 10 epochs, so it's going over data 10 times. But I wonder why it's not using 10x data instead. Why is it going 10 times over same data, 10 epochs? So let's see if it already used all of the data. But it says it's now using test data to train on. It already used all 60,000, so we don't want that. We want to keep test data separate. I connected with Novita just with terminal, so I'm pulling from GitHub because I struggle to connect this Kiro ID, but cursor can connect, so I can connect cursor. Here it works. So you can just do this in Novita. You can connect with SSH your whole interface. So one epoch takes about 1 minute, so we will wait for 10 minutes. Let's now understand the code. So image size 32 pixels, that's very low. Usually these images have 500 pixels, but this is gonna make it so easy for us. Train batch size. So I have this GPU monitor file that I'm running in different terminal, and we can see that we are not utilizing our GPU completely. So we should have increased this batch size. And maybe we would finish the training in 4 or 5 minutes instead. And this is the GitHub repository for all of this. I will leave it to you below. Fast image diffusion. Number of epochs, we go 10 times over the data. Gradient accumulation steps, this is just simulating higher batch size. For now, it's just 1. So it's not gonna accumulate steps more than 1 batch. Learning rate, warm-up steps, we'll see, we have some kind of scheduling learning rate. So then for data, you're using datasets from Hugging Face, I believe, and you're using this load dataset to load these digits, and the torchvision.transforms to transform the dataset. And this is how we load mnist, so datasets.load dataset mnist, and then just split train. So these are our handwritten digits. Then we will resize from 28 times 28 to 32 times 32. I guess this is because this will actually give us more speed, because these are powers of 2. That's why I think it decided to resize. AI Claude decided to resize. Convert to tensor, so we work with it in PyTorch, and normalize between -1 and 1, so numbers are stable, there is no gradient explosion and stuff. So then that's the pre-process. So we will pass each image through this pre-process, going in through the dataset, and then return images. So we will wrap this transformed dataset in PyTorch data loader, batching it for training. Then we are defining our model UNet, which I thought I was using transformer, but okay, we'll use transformer later. Transformer will scale better if we add more GPUs than UNet. But for now, UNet works also well on single GPU. So we are creating UNet using Hugging Face's diffusers library. The characteristics of this model: input, noisy version of image plus timestamp; output, prediction of the noise. No conditions, so we are not writing any text. I actually want to be able to write digits 1 to 9 and then generate those. And channels, it's just 1 grayscale, 1 input and 1 output. So it's not like RGB 3 colors, it's just 1 color for grayscale. Then we set up this noise schedule. We are just gonna use diffusers.ddpm scheduler. So we have 200 time steps to generate, go from the noise to image. And I wonder what DDPM stands for. Forward goes clean image, gradually adding noise, so forward diffusion, and then reverse diffusion. Model learns to predict and remove this added noise. So we know what noise we added, so we teach the model to step by step predict that noise. And then we just subtract noise from the noised image. In the end, we get clean image. We will use classic MuP Optimizer. Very classic. We should maybe start using MuP Optimizer. It would learn more, it would learn faster. Maybe 50% faster. But for now, let's use MuP. And learning rate cosine schedule with warm-up. So it goes like this. It goes from 0 very quickly, becomes high learning rate, and then slowly goes down over the training. So early images are, when it rises up in the beginning of the training, will contribute most to changing weights. And as it learns, later images will not change weights so drastically. So it's gonna just refine towards the end. It looks like loss is consistently going down over training epochs. So maybe even 10 is too low. And if we use the MuP Optimizer, this would go even further down by now. The loss would be even more lower. Now that we trained it for a lot of epochs, some numbers are actually better looking, but looks like these labels are not even matching. This is 0, this is 6, it says 8, so labels are not matching. But it looks better. Now I want to make it transformer, I want to add muon, I want to probably add BF16, I want to make it conditioned on numbers so I can write numbers maybe, and it will generate, it's writing a lot of code here. Now our code base, because we just imported finished UNet, but now we need to code transformer from scratch. So this is diffusion transformer, which we convert these images into 4x4 patches, 64 patches per image in total. We also have this timestamp embedding where we convert the timestamp of the noise to like some sine wave or something, or vector, because AI can learn a lot more if it has a vector, a bunch of numbers, than a single number. So it can use that to adjust, to calculate other weights, to extract data from that. Next, I have this very optimized LLM, that's my LLM, my code. And you can find this in the video, publish your own LLM. So I have a lot of optimizations there, including MuP Optimizer. And so I told it to apply optimizations from my LLM to this diffusion transformer. So this is the MuP Optimizer. We need to hand code it right now. It's not present in PyTorch to the best of my knowledge. It's very new and it's very good. But maybe for such a small model, we didn't actually need transformer, and I should have just trained it longer, and then I should have maybe create distilled version of the model so it generates faster. But also maybe I'm gonna use CIFAR10 dataset. These are actual images, but they are low resolution, but they are actual images, so we can maybe generate these. So now my diffusion transformer works. There is also MuP Optimizer. It's training for just 3 minutes. That's actually quite good. Why is it 5,000 steps? I don't know. But it looks like compute and memory are not being utilized at all. So I need to tell this, utilize this better. So image size increased. Why? Why did it increase image size? I'm gonna reduce this. We don't get anything. But train batch size, that's good. Gradient accumulation, just 1, okay. Transformer, more higher patch size, number of layers, number of heads. Okay, I'll just let this run and see. It says here what it did. I don't know why it increased image size. It shouldn't, maybe it doesn't know that it will not do anything, I think. So let me check these changes. This is to train, it already saw that. We also have some mixed precision, and we have BF16. Yes, I wanted to tell it to use BF16 instead of FP16, which is BF16 is made for machine learning, for neural networks. Okay, some of the numbers are really nice. This 8 and 5, ignore these labels, they are not correct. This is 3. Now I will just tell it use CIFAR10 instead of MNIST digit, so this is the better dataset. This is real images. And this max auto-tune in compiling doesn't work so well, you see. It takes too much time. I'm gonna say reduce overhead. And this is good when we are just testing, we need quick compilation. And max auto-tuning is when you wanna like train for a week. So it will auto-tune for a long time to make training faster. What do you mean enable TensorFlow 32 for faster training? What? We are downloading dataset and we are using now 32 times 32 RGB images. It's generating images quite nicely, creating some interpolations, creating some other stuff. Okay, let's see the first image. What is this, bro? What is this? I see our patches where we split images into patches. It's definitely not enough training is what it is. Yeah, we cannot just train for 5 minutes and expect amazing image generation model. At least there is some coherence. So this is red, there is red stuff around. I'm gonna leave this GitHub repository down below and you can maybe experiment on this and see you next time.